All right. So let's go to lithium now. Look at where lithium is. Lithium, all right, is not on the same row. So it's not the same primary level. Okay? It's on the next primary level. Okay? So now we don't get rid of 1s. 1s stays there. Every time we add a new atom, we're going to build on the previous orbital notation. Okay? So 1s is going to remain there. Those two electrons are not going to move. This is a ground state atom. They're going to be there. But now we need to put our electron in a second primary level. So it can't be in 1. It's got to be in 2. And what region are we in here? Still in S, so this has got to be a 2s. So how many more electrons do I need?
1.
There you go. That's the orbital notation for lithium.
Will we always have to draw a box, or can we just draw just a single area?
No, you have to draw a box. Okay? All right.
There will always be up and down arrow, never a down and an up arrow.
It always starts with the up arrow. And that's for reasons that kind of go beyond the scope of the class here. Your head's already about to explode. Let's don't add more stuff to it, okay? Yep.
Okay, so that's like beryllium. It'd be like that, but then be like it would have 1s, 2s with a down arrow in it.
Say again? I'm sorry.
It's like beryllium.
Uh-huh.
Okay, so you'd have like the 1s, the 2s, like that, but then would you just add a down arrow to the...
You absolutely would. Let's do that. There you go. See? And she was gone part of the time, and she's already caught up here. That's great. There we go. It just keeps going on and on.
So like 100. Wait,
Yeah.
it would be like... Okay, what if you had to do potassium?
Well, can we get to potassium a little bit later after we do some more of these?
I mean, are we going to work all the way up to that? Because that's a lot.
I know we'll get there though. Trust me, we'll get there. Okay?
But I'm
Yeah.
just saying, what if...
Could you briefly explain the arrows, like why they have to be up and down? Is there any blue?
It just indicates their opposite spins.
Right.
When we get back to when we go back and do quantum numbers, some of that'll make sense too.
You said it goes beyond the scope of the class.
Oh, about why they have to do that? Why they have to have opposite
Is
spins?
there any brief explanation?
Well, no, I thought I explained that because you can't get two particles that have the same charge and stick close to each other.
I mean, like, why it can't be like a down and then...
Oh, down and up. All right. Down and up, or right and left, in this context, is purely theoretical. Okay? Scientists have pretty much agreed that the first electron in an orbital has the same sort of state that we represent as a spin, and it has the second electron that joins there has to change its state or its spin, and so we just simply represent it up and down. That's as simple an explanation as I can think of. Okay? Yeah. Sure. Yes.
Does that work the same way when you get into the D?
Pretty much. There are some things that kind of go off track here a little bit, but it'll be all right. Trust me, you'll be fine. All right. What's the next atom? Boron. Okay. All right. So we're going to build on what we already got. Here's 1s. Here's 2s. Okay. But now boron's electron must be in a different region because it's in a different region. What region is it in? P. What row are we in? Still in the second row, so this must be 2p. Okay? So, question. How many electrons can I put in an orbital? 2. How many elements in this region on that row? 6. So how many orbitals am I going to need for all these? 2 electrons in each orbital, 6 elements, that's 3 orbitals. Okay? So we need 3 orbitals for the p sublevels. Now remember I told you they could be empty. Some of these are going to be empty. For boron, we're just going to put 1 electron in there. Okay?
So we don't usually write 1p?
No, there is no 1p.
But what about when hydrogen moves over to helium?
Yeah, there's still only, in the first primary level, there is only an S sublevel. And it has to do with the three-dimensional geometry within that spherical shape we call a primary level. Yes?
So why are there 3 boxes?
Because the p sublevel has 3 orbitals. Okay? Why?
Why do you have 2p? Like, where did you get that from?
It's the second primary energy level. We're in the second row. That represents the second primary energy level. So as we remember, when we stack electrons, they have to stay a certain distance apart. We can only get 2 close together, right? So they're arranging themselves around the central part of the atom we call the nucleus, where the positive charges are. So they're attracted to those, but they can't get too close together. So they arrange themselves three-dimensionally like this.
But I thought the rows were just like the sublevels, not the primary levels.
The rows correspond to primary levels. Sublevels are represented by these regions like right here. Yep. When she comes back, wait, does he go without pass? Oh, huh? When she comes back?
Wait a second. So the sublevels are the S, P, D, and F.
Yes.
Okay, and then in the S sublevel, you're only gonna have one box. Okay.
Yes. S sublevels only have one box.
Okay.
Okay. All right. That's boron. How about carbon? Now, here's the trick. Here's where we start to get we need to know a little more information. Okay? And I like to call this the school bus rule. All right? The school bus rule. It's really simple. Let's see where did I put my thing. All right. Let's imagine for a minute that this is the first day of school in first grade. And you've never been to this school before, and you all are going to have to ride the bus. And you don't know anybody on that bus route. Okay? So Josh over there, he gets on the bus, and he's the first person on the route. Okay? Where's he going to sit on that bus?
In the front.
In the front, on the first seat, somewhere close, right? Okay? All right. All right. Now, Bailey doesn't know Josh. Bailey's shy, first grade. You know how that is, right? She doesn't know Josh. She's a little scared, a little timid. She gets on that bus. Josh is on there. Where's she going to sit?
Somewhere else.
Somewhere else. So she's not going to sit on the seat with him now, is she? All right. Now, Stephen gets on the bus, and I know Stephen's sort of outgoing and everything, but remember, he's a first grader, and he's shy, all right? First time on the bus, Stephen. Okay? Golly. All right. He's shy. He gets on the bus. Where's he going to sit?
Away from us.
He's going to sit on the third seat. Now, I know that there are no buses with only 3 seats. I know, okay? But let's imagine for a minute this bus only has 3 seats. Okay? So 3 seats. Okay, now bus seats, we're going to seat 2 people, right? All right. So Chandler gets on the bus. What's she got to do? Sit with somebody, right? All right. Carson, what's Carson going to do?
I'm gonna sit with somebody.
Okay. You got to, right? You don't have any choice. All right. Well, the school bus rule kind of works the same way. Well, no, nobody's going to sit on the bus driver won't let you sit on the floor. All right. So here's how the school bus rule works, guys. Pay attention. All right, so remember we're going to have these 1s and 2s sublevels that are full, and we get to 2p, and here's Josh. He's on that first seat right here. Okay, there he is. Okay, along comes Bailey, and she gets in another seat. Okay, and then Stephen, he gets in another seat. All right? And poor Chandler, she didn't have a choice. Those are all up arrows. Well, it's called we're calling it the school bus rule. Okay? There is a reason for it, but let's don't sweat that part too much right now, okay? All right? All right. So, Chandler gets on the bus, and I know she'd probably rather sit next to Bailey than Joshua, but let's just put her next to Joshua anyway, okay? All right? Okay? All right. That's the way they fill up. Now, that's not carbon because carbon only has 2 electrons, right? So carbon is going to have 1 electron here and here. Okay? That's carbon. That's carbon, right? I'm just explaining what's going to happen as we go through this P sublevel. Oh, but it's going to keep repeating and repeating and repeating. You can get it. You'll get it. You get it. Trust me. My CP class got it in 2 days. They got it. You can do it.
Well, we're trying to get it in 1.
Well, we're kind of getting a little bit different start here. Yes.
I still don't understand why you have 2 boxes.
Because I need 6 electrons to fit in that 2p sublevel.
But why do you note them if you don't need them for that one?
Because the space still exists even though you don't have an electron there.
There's empty orbitals.
They're empty orbitals.
Oh, so you have to. Okay.
Okay, they represent empty orbitals because the space within that region still exists there, even though there's no electron in it. Okay? All right, so that's carbon. And let's see, our next one is going to be nitrogen. And I bet y'all can do nitrogen already, can't you? Do nitrogen for me. Come on, you can do nitrogen. You already got it going here. Trust the force, Luke. You got it going. Oh, I forgot we do have a Luke in here, don't we?
So, in the whole school bus thing,
Mm-hmm.
we don't do up and down, we keep going like this, up, and then we go down, down.
Exactly. So when we get to oxygen, the next element, that's where Chandler's got to sit next to Josh. Okay? That's a terrible thing, I know. Okay?